the last class we were talking about elements of test of hypothesis. So we looked at this table and we have, this is the type 1 error versus type 2 error. Type 1 error is rejecting a true null hypothesis, that is fixed, right, rejecting a true null hypothesis, that is fixed, because we fix that alpha to be lower or 1 minus alpha to be higher depending upon the situation, right. So this alpha is fixed, type 1 error is nothing but alpha. Type 2 error is not rejecting a false null, this cannot be 1 minus alpha, you understand, because then, so the total table should add up to what? The total table should add up to 1 or 100%, because that is the sample space, right, the entire out table is the sample space. So the sample space should add up to 1, right, that is 100%. So if your half diagonals add up to 100, 1 minus alpha plus alpha, then your diagonals you never have a correct answer, okay. So that cannot be the case by common sense. So beta is the type 2 error, and of course if alpha increases beta will decrease and vice versa. So they have an inverse relationship, that much should be very clear, okay. Now what is beta and so on, we will, how to determine beta we will learn later, okay. So these are the steps of at hypothesis testing, we will do a few problems, but these are the steps of a hypothesis testing, okay. So we have a null hypothesis which is status quo, okay, very simple, that could be simply like a population parameter mu equals to mu naught. Remember the hypothesis is never on a sample, again not to be confused, the sample and population should be very clear in your mind. The this thing, the null hypothesis is always on the population, you are only using the statistic to infer. So the null hypothesis is about the population, mu equals to mu naught, okay. You could have anything mu greater than mu less than, usually mu equals to mu naught. The alternate could be simply a one sided or a two sided hypothesis, mu naught equals to mu naught is a, what do I call, is a two sided hypothesis, meaning it could be less than, it could be greater than, right. So this is a two sided hypothesis, two sided HA, okay, or you could have mu greater than mu naught or mu less than mu naught, which is one sided. What is the difference between this two sided and one sided? Why do I specify explicitly two sided and one sided? What will change between one sided and two sided hypothesis? What will change between one sided and two sided hypothesis? Huh? I am still interested in the population parameter mu. What will change between a one sided hypothesis and a two sided hypothesis? Distribution is normal, what else? X bar, you are talking about distribution of X bar does not care about the underlying population, then no decent answers, nobody is even close by. Your acceptance region and rejection region will have to change, your acceptance and rejection region has to change. Why? Because if you look at mu naught equals to mu naught, that means what? This entire region is acceptance, right, mu equals to mu naught, this entire region is acceptance, anything beyond that in both the extremities is a rejection. Whereas when mu is greater than mu naught, I do not care about the left side, I only care about the right hand side, okay. So only beyond the right hand side critical, this thing, your rejection region is only on the right hand side when mu is greater than mu naught, and when mu is less than mu naught, your rejection is only on the left hand side, okay. So your acceptance rejection regions, and therefore your value of Z alpha will change in simply alpha by 2 will become alpha if it is one sided test, because I do not care about the other region. So, I will not do alpha by 2, I will do z alpha if it is a one sided region, okay, and plus if it is x mu equals to x bar plus z alpha into sigma by root n if it is what right hand side, and if it is left hand side it will be mu equals to, so here mu equals to x bar plus z alpha into sigma over root n, and in this case mu equals to x bar minus z alpha into sigma over root n, okay.
This terminology mu is x bar and mu naught is mu bar.
So, in this terminology, so mu naught is my null, mu is my pop, so what am I saying, mu naught is my assumption about mu, mu naught is my assumption about mu. I am saying the population mean is let us say 50, that is 50 is my mu naught, true mean I do not know, that is still mu, okay. Now what am I validating, my null hypothesis is the population mean is equal to my assumption which is my 50, that is what I want to reject, status quo, right. So the
X bar is also assumption about population.
x bar is an estimate about population mean, it is not an assumption, it is an estimate of the population mean, whereas your mu naught is your assumption about the underlying distribution itself. You assume some value based on whatever, like I say mu naught of the underlying distribution is some number, I have not come up with it statistically, it is the status quo, it is the status quo, you understand. Then I have collected data, and after collecting data what do I want? I want to reject or accept the null hypothesis based on the, yes, that is all, got it. It is as simple as it is, clear, does it make sense? We will solve a problem, then you will know, okay. And then the test statistic is nothing but the sample statistic to be used to test the hypothesis, okay, sample statistic to be used to test the hypothesis. What is in our case for mu? So you have null hypothesis, you have alternate hypothesis is of two types, one is the two sided hypothesis, the other one is a one sided hypothesis, and then you have a test statistics. So the test statistic is what? In this case what is the test statistic? What is the statistic we are using to estimate mu? Huh? What is the statistic you use to estimate mu? X bar, that is all. Your test statistic is x bar. I told you what is sample statistic, it is a estimator used to estimate the population parameter, in this case it is going to be x bar. And what is your rejection region? What is your rejection region? What is your rejection region? How do you determine the rejection region? For a two sided, anything greater than mu plus or minus x bar plus or minus. So coming back, so what is my rejection ratio, rejection region? For one sided, two sided, it will be both ends. So the rejection point or the starting is x bar plus or minus z alpha by 2 into sigma by root n, comma x bar plus z alpha into sigma by root n and x bar minus z alpha into sigma over root n depending upon the hypothesis, right. This is the critical point, we call it as the critical point, beyond which it is the rejection region. So this is my critical points. Beyond which you start rejecting, clear. And what are the assumptions? central limit theorem. That is a inherent assumption you are making, okay. Apart from whatever assumptions you make during sampling etc., the inherent assumption is central limit theorem, clear. And conclusion is reject the null hypothesis with possible type 1 error, or do not reject it with possible type 2 error. Remember, whatever conclusion you make, you will make with error, okay. So one side you will have a type 1 error, that is if you reject null you have a type 2 error, if you accept null you have a, so if you reject null it is type 1, if you accept null you have a type 2 error. Make sense everyone? So far so good? Okay. So this is a problem that I want you guys to solve, okay. So tell me the H0, HA rejection region, the the test statistic, the critical points, rejection region with conclusion. Go ahead, unless you do it you will not learn. What is your H0? What is your H0? Somebody. What is my H0? Huh? Look at the problem, what is H0? What is the in terms of numerics? Huh? What is mu naught? Mu naught is 4, why 4.7? Mu naught is 4. What is my alternate hypothesis? Huh? Mu naught is 4.7 is my alternate hypothesis. So is it a two-sided or one-sided hypothesis? It is a two-sided hypothesis. So what do I have? What is my test statistic? What is my test statistic? What is the value? Test statistic. What is test statistic first? X bar equals to, what is my standard deviation? Yes. Critical points. What are the critical points? X bar plus Z alpha by 2 sigma over root n. It is a two sided, so you have both. It is 4 plus 0.5 by root n is root of 121, which is 11, into Z alpha by 2 is 1.96, because this is 95%. Okay, right? So now this test statistic is X bar. Do you operate with X bar like this? Do you operate with X bar like this? There is a catch here. What is the catch? We are comparing against standard normal. So what should I do? I should convert the X bar also to standard normal. So my test statistic is not X bar alone, my test statistic is normalized X bar, which is Z star, right. So because these two are, that is a catch. So you always compare against your standard normal distribution. So your X bar also has to be normalized, made into standard normal. So that is where you do X bar minus mu naught. Mu naught is my status quo, that is where comparison happens. X bar minus mu naught by S of x bar is given to which is 0.5. So now you have the test statistic value. Now is this test statistic beyond the region? Of course yes, it is beyond Z alpha by 2 which is 0.105. So this is what it is. In other words, what you have done is critical points is this, right. So now you compare, you rearrange this. So what do we do? Mu minus x bar by Z alpha by 2 into sigma by root n should be equals to x bar. What is it? Okay, because I will lose the continuity. You do not want to lose this continuity. Okay. So if you look at the critical points, right. Now I know Z alpha by 2, Z alpha by 2 for is known, right, because it is 95% confidence. Then what do? X bar minus mu by sigma over root n should be equals to, should be less than or equals to Z alpha by 2 for acceptance and should be greater than or equal to Z alpha by 2 for rejection. Okay, very simple. So that is what we do here. We actually standardize x bar also. In this case mu naught is known to you, okay, that is the average, given average, x bar is 4.7 and you divide it by standard deviation of x bar which is also given to you. So that becomes your z. This z has to be compared with your z alpha by 2 because it is a two sided hypothesis. If it is a one sided hypothesis, it will be compared with z alpha, that is all. Clear? Simple idea. I think 0.5, why is it, what is, no, okay, sigma by root n, right? No, this is standard deviation of the original. So look at this, a sample of 120 cards produced an average of 4.7 and per game with a standard deviation of 0.5 cards. What is the standard deviation? This is standard deviation of x bar. This is standard deviation of the x calculated from data. What is standard deviation of x bar? What is standard deviation of x bar? 0.5 divided by 11. 0.5 divided by 11, what is the answer? That is what you will get. Correct? Can you calculate? 0.5 divided by square root of 121. It should be that way. I think there is a mistake here. That should be point. This is Sx bar should be point. It cannot be 0.064. 0.04. 04, right? That is what they would, there is a calculation error. Because this is sigma over root n. It cannot be sigma. So this 0.5 is not Sx bar. Okay. This 0.5 is the sampling deviation, standard deviation of the sample you have got, right. You have taken samples and the standard deviation of the sample is 0.04, 0.5, that is Sx, okay, it is not sigma x, Sx. Sx bar is Sx by square root of n because you do not know the true sigma. Clear? So this should be 0.04, right? I do not know where. Sigma over root n. So can we do another problem? So I will at least do 2 problems, then you are at least clear about it. Can we solve this one? See, I have given you in this case an estimated standard error. What is standard error? Is nothing but sigma over root n. So, I have directly given Sx bar here, okay. So, that is where when I give you standard deviation versus a standard error, that is what the difference is. This problem, in this problem we have given you the standard error, that itself standard error means it is Sx bar, which is equal to sigma over root n. By the way, in the exam do not expect this kind of silly problems, okay. That is why I was wondering when you asked me tables, probably you are new, some of them are known too. You will not be able to, I will not let you remember or make you pain you by asking you to remember anything, correct? Okay, good. Everyone, shall we try this? You have your mobile anyway, you can use it as a calculator for some time, you can try this. This is pretty straightforward. Mu equals to 60,000, mu naught is 60,000, okay, mu naught not equals to 60,000, x bar minus, okay, so this is, okay, x bar minus mu naught divided by sigma x bar, okay, that is what, this is my mu naught, 60,000 is my mu naught, this is my mu naught, this is my mu naught, okay, and you directly compute x bar minus mu by sigma over root n, z is 0.613, okay, rejection region is z greater than z 0.025 both the sides, okay. So, you are not going to reject the null hypothesis, okay. From looking at the problem only you should have an idea why the change in mu average is around 1340, the standard error is 2000 plus, okay, that itself should give you an idea whether you will be able to reject or accept the null, okay. Just looking at the numbers only you should be able to take a guess, because look 60,000 to 61,340, the average change is only 1340 with the standard deviation of standard error of 2000 plus, 60 plus 2000, 62, 58, you are only talking about 60,000, 61,500 close to, so it will not be able to reject the null for sure, okay. Just looking at the problem you should have an idea about the answer, okay.